Okay, so this question continues, and here is the hard part, right? So this is the aliasing question that we've been waiting for. It asks, list the 3 lowest frequency signals other than this one in increasing order that will alias with this signal. Okay, so you're asked to give 3 additional frequencies. So, so just a brief review of the relationship, before we solve that question, of the relationships between the frequencies, the sampling frequency, and the alias frequency. So in class, we taught 2 ways to do this, or 2 ways to represent this relationship. One was a formula. In the formula, G was the alias frequency. Is this on the page? Or just barely? F is the frequency in question, so we'll call that frequency. And F sub S was the sampling frequency. And this was part of the formula here. So what it says is that given a frequency F, it aliases to the frequency G according to this formula in a way that F minus some integer multiple of F minus an integer multiple of Fs, when you take the absolute value, gives you the alias frequency, as long as that alias frequency is between 0 and Fs divided by 2, right? So this particular formula can evaluate to lots of different things, depending on the value of m, but only one of those will be in this range, and that's the one that's equal to G. So I really don't like this formula because it's quite complicated. So we did teach you a different way to understand this formula, and I find that much more revealing. So we basically, in class, showed you a picture, a graph that relates F and G. What I'm doing here is I'm going to describe the function that maps F to G. And it looks like a sawtooth, right? So I think this this kind of picture is worth drawing on your A sheet for the kind of question that comes up. So it's a sawtooth picture, and it touches down at Fs, the sampling frequency. It also touches down at 2Fs, and so on. It continues. So if you know that it touches down here, you should pretty quickly be able to write down that the peaks are at Fs divided by 2 and at 3Fs divided by 2. So again, this is a very standard picture. You can, everything that I'm drawing so far should be on your H sheet. And likewise, the peak here, the peak value is Fs divided by 2. Because each of these sawtooth lines, they either have slope equal to 1 when they're going up and slope equal to -1 when they're going down, right? So if you have this picture, you should be able to answer all the questions. So let's go back to our question. Let's put it down here. List the 3 lowest frequency signals other than this one in increasing order that alias with this signal, right? So we can, the first thing to do here with this picture is to fill in some of the information that we know. We know that F sub S is equal to 2 megahertz. And therefore this over here is 1 megahertz. That point is 3 megahertz, and that one is 4 megahertz. Okay, so that comes from an earlier part of the question. Right, that was what we derived back in part A. And we know that our F, our original F, is 0.833 megahertz. So that lives somewhere over here. This is our original F, which was 0.833 megahertz. It's a little bit less than 1 megahertz, which is why I drew it there. So this, we said that this signal does not alias. You know, there's no aliasing of this signal, which is verified by this picture because f maps to a value of g, which is also equal to 0.833 megahertz. Right? So the picture confirms that there's no aliasing because it ends up at the same value of frequency. I can see some questions about that. Is that not clear? What I'm doing here is this solid line, the sawtooth signal, is the relationship between f and g. So if I give you a value of f here of 0.833 megahertz, I can read off the corresponding value of g by going right here. And since it's the same thing, you know, the same frequency, it stays at its own frequency. It doesn't change, it's not alias. Now the question asks, list the 3 lowest frequency signals other than this one that alias with this signal. So we're looking for other frequencies along here that give you the same value of g. Right? So it's very simple. All you have to do for this kind of question is extend that value of g, right, the 0.833 megahertz, and find these values right here, right? Those 3 question marks will be the 3 frequencies that alias to 0.833 megahertz, the 3 other frequencies that you're looking for. So we've got to determine these. Now, fortunately, there's a lot of symmetry in this sawtooth signal. So what we can do is exploit that symmetry to get the answer. So, for instance, this one right here, the very first one, it is the same distance. Well, if you look at this unknown frequency in f, then it's got fs divided by 2 right in between, right, by symmetry here. It's 1 megahertz in between. So the distance from f to fs divided by 2, which turns out to be 0.167 megahertz, is the same as this distance over here. So that frequency, call it f1, is 1.167 megahertz. Because it's got to be on the on the other side, the same distance over. No, G is still 0.833 megahertz for all of these signals. So that difference, I mean, that difference is something, but it's not G. I mean, you could interpret it in this formula, but at the top, but it's, I don't see the value in doing that. I think it's more confusing than anything. So I won't. Okay, so we've still got 2 unknown frequencies to figure out. But these are easy because we know that f is 0.833 and the first f1 is 1.167, and they're equally spaced around 1 megahertz. You're going to have the same relationship around this point, which is 3 megahertz. So these 2 are 2.833 megahertz and 3.167 megahertz, right? And so those are our 3 answers. Okay. Now I think this question, I never actually tried to solve it using the equation.